In this video, I'll be working through the question you see on the screen here from the Maths paper 1-2 from 2024 Cambridge A-Level exams. If you're looking for a different question from this paper, have a look at the playlist that I've linked in the description below. If you're looking for a different paper entirely, have a search on my channel. I'll be doing all this on the whiteboard, hopefully just like you're used to in the classroom. But remember, we're not in the classroom, we're on YouTube, so take advantage of that. Pause, rewind, even watch it at double speed. If you find this video or any of my videos useful, I would greatly appreciate a like, a subscribe, a share, or even a super thanks. Question 4 starts off by giving us the function the square root of x and minus 1, and they tell us x is bigger than 1. And then they ask us to find an expression of the inverse of this function. This is a great example of you need to be careful to read the question. I went and differentiated this when I was going through the work before looking at the question again and going, oh no, that's the inverse they wanted, not the derivative. And I'm sure a few students did the same. So the inverse of a function. The inverse is just, we put x into a function, we get y out. The inverse is, what if that was reversed? What if, what function, so if you put 1 in, and let's see, what happens when you put, x is bigger than 1. What happens if you put 4 in this? Square root of 4 is 2. 2 minus 1 is 1. So we put 4 in and we get 1 out. What function would, where we could put 1 in and get 4 out? But it has to work for every single number. So really it's just the x and the y change places. So when I say y is just the generic word for what an answer to a function is. So instead of y we could use this, but much more common to use y and easier to write. So y is equal to this. And let's just switch places. Let's write x is equal to the square root of y minus 1. And now if we get y on its own, we have the inverse. The switching places itself has brought us into the inverse world. This is the normal world, this is now the inverse world. And we just rearrange it and get y equals. So that becomes x plus 1 is equal to square root of y. We square both sides. Nothing weird's going on when we square, because like getting the root introduces plus and minuses, but squaring both sides nice and easy and safe. X plus 1 squared, and that's it. Well, if I write that the other way, or once y is on its own, remember we're in the inverse world, so the function we're talking about here is the inverse function. So that's the inverse of x is equal to x plus 1 squared. Part B goes on to give us this drawing of gx, a different function. This is 1 divided by x squared plus 2, and it looks roughly like this. They ask to state the range of gx. So what's the range of gx? What's the smallest gx can become, and what's the biggest gx can become? What range is it in? Now you can mostly see from the picture, but we are going to have to think about the maths a bit. Mostly we can see from the picture, the lowest it gets is the 0 line. And the highest it gets is whatever this point here is. So we need to figure that number out. So we're going to have to do a little bit of maths on that. Also we'll have to talk about, is this 0 and what's going on there. Then also they ask us to explain whether the inverse of this exists. I'll leave that for a moment. Let's deal with the highest and lowest point. Let's find this highest point here first. How do we find this? It's at 0. It seems to be, at least. We could differentiate, but you don't have to in this case. To be safe, you could differentiate, find the maximum. You'll find it, I think, 3. Yeah, you'll get cubic. You will find 3 answers. That'll be plus infinity, minus infinity, and the x equals 0 in this case. But we can just guess from the picture. They've given us a pretty good picture here. This is the maximum, 0 is the maximum. It's a fairly symmetrical function. So I just want to find g0. And if I put 0 in, I'll just get a half. And that's the highest this function goes. And it does equal it. So it is less than or equal. This is the range again. It's less than or equal to half. I would just want to talk about, does it get to 0? We can put some numbers in. We can put 100 in. 100 squared is 10,000. 10,002. 1 divided by 10,002. It's a small number. It's not 0 though. What if we put 1,000,000 in? Million squared is a trillion. That's a really small number. What if we put a billion in? What if we put bigger and bigger numbers in? We can get this as small as we want. It'll be tiny. It'll be so close to 0, it won't matter. But importantly, it will never touch it. So the range is 0, the bottom of the range, but it'll never touch it, so you can't put an equals here. I'm not sure if they'll take a mark away for that. They probably should, but they might be nice to you not. So this is the range. This is the range. When it goes to when x is really small, minus infinity, it's nearly 0. When x is really big, plus infinity, it's nearly 0. That's the lowest we can get on this function. And the highest we can get is when x is 0. Another way to think of that is the highest a dividing function will get is when the bottom row is the smallest it can get. So what's the smallest this can get? And that'd be actually easier if you want to differentiate that. X squared, let's say y is equal x squared plus 2. This function on the bottom, what's the smallest it gets? Well, that's the derivative of it, dy dx equals 2x when that equals 0, and that's when x equals 0. Just to prove that the maximum is at 0 here. The bottom row is minimum at 0. Anyway, that's the answer to part B. Oh yes, explain whether it has an inverse. So does it have an inverse? Remember what we said about inverse. Inverse is x goes in, y comes out, the opposite, then we opposite that. So think of here, let's say minus 10 goes in, and I don't know, let's say 1 over 10 comes out. Look, whatever, it doesn't matter what it is, 1 over 100 comes out. Okay, and then if plus 10 goes in, 1 over 100 comes out. The problem there is, what's the opposite to that? The opposite is 1 over 100 goes in and 10 comes out. But 1 over 100 goes in and minus 10 comes out. Which comes out? We have no idea. So you might want to say something like that. Too many things come out. There's too many options. You can waffle like that. The more correct thing to say is this function is many to 1. And so the inverse would be 1 to many. And 1 to many is not allowed. A function can't be 1 to many and be a proper function. Another way you could say it is it fails the horizontal line test. And that's just if you can put a line across and hit the function twice, then it can't have an inverse. So you could say either of those. I'm sure there's a few other fancy ways. Your book will tell you. The idea though is that this function, if you put one thing, there's many things you can put in to get one answer. You can get 1 over 100 by putting 10 in or minus 10. I realise that's slightly wrong because that's 2, but roughly. So you can put many things in and get the same answer. So the inverse, and we can never have a function that one thing goes in and many things come out. It'd be too confusing. What's the answer? What's the answer when we put it in? If you draw this, if you try and inverse this, it would look like, I guess it would look something like this, I think. And functions aren't allowed to go back on themselves, if you know what I mean. It's too confusing. It's if I put x in, what do I get out? Do I get this or do I get this? Okay, on to part C. We keep the same function here, except it's called hx this time. And they ask us to solve the equation hfx is equal to f25 over 16. Let's remind ourselves what f was. Fx was equal to the square root of x minus 1. So they want us to solve this equation. And remember, this is h now. Let's just change this to a hx. Okay. First of all, what's this hf? Some students are confused. Just add an extra bracket in, and that fixes it for me at least. A number, just something goes in here, and whatever goes in here, we get 1 divided by the square of it, and we add 2. Whatever's in there. So I can write this again as, and then fx is just this. So I can write this again as the h is 1 divided by whatever squared plus 2. Quick edit for the phone call. Where was I? I was saying so this is h. 1 over something squared plus 2. That something in this case is just fx. And fx is the square root of x minus 1. And that equals f of of, was that 25 over 16. And f is just the square root of whatever's in here, which is 25 over 16 minus 1. This is what they're asking us to solve. And by solve, they mean find x. Because this is just one equation with now one unknown. So yeah, they will ask something like this. You need to get good at filling a function like this out and getting all the information in. So let's just get to work here. This side's nice and easy. It's the square root of 25 is 5. Square root of 16 is 4. That's 5 over 4 minus 1. That's 1 over 4. That's quite easy. Let's just do that now. 1 over 4. Let's change sides. Multiply both sides by 4. That'll come up here. Multiply both sides by this expression. That'll come up. So that'll leave me to 4 is equal square root of x minus 1. X minus 1 squared plus. Actually, that's wrong, isn't it? That should be x minus 1. There we go. X square root of x minus 1 squared. Be careful on these things. So now we just have to solve this. Let's start. Well, we could square it out and get a quadratic, which now that I think about it is what I did in my notes. But looking at it, there's a much easier way. So yeah, go ahead, square this out. You'll get an x. You'll get a square root of x, and you'll get a number without anything in it. That's a quadratic, but it looks weird because it's in the square root of x. Don't need to do that because there's all the x's are in one spot here. So let's get the 2 over, and we'll have square root of x minus 1 squared is equal to 2, or I'll write this equal to 2. We then get the square root of both sides. That'll give us square root of x minus 1 is equal to plus or minus the square root of 2. We have information about x being bigger than 0, so we can probably eliminate one of these. It's just x isn't on its own here yet. But also, square roots have to be positive, so that's going to help us. I'll just leave this for one extra line before it'll fix itself. But do bear in mind, when you get pluses and minuses, often there's a way to get rid of one of them. Not all the time. Sometimes we get 2 answers. But there's often a way to get rid of one of them. And we'll see that next line. Let's add the 1 to both sides. Square root of x is equal to 1 plus or minus the square root of 2. Square root of x has to be positive. First of all, x is positive, they tell us. But also the square root of any number, unless we're dealing with complex numbers, is positive. So this number has to be positive. So let's look at that. 1 plus the square root of 2. You put that in a calculator, but square root of 2 is about, is it 1.6 I think? Doesn't really matter anyway. It's certainly bigger than 1. So 1 plus something bigger than 1 is a positive number. That's fine. The problem here is if we use the minus. 1 take away square root of 2. That's less than 0. And we can't be less than 0. So that minus wouldn't have worked. You could do that in your head over here. But once the examiner sees you get rid of it at some stage, you're fine. So lots of students probably left this as the answer. Feels like the answer, feels like you've got there. They ask you to put the answer in the form of a number and a square root. This feels good. The problem is they didn't ask for square root of x. Well, actually they didn't ask for x, they just said solve it. But when we're asked to solve a function, we want to know what x is, not square root of x. So x is equal to 1 plus square root of 2 squared. That's an okay answer, but they didn't ask it to look like this. Square that out, we get 1 plus 2 square root 2, and this squared is plus 2. 1 and 2 is 3 plus 2 square root 2. And that is how they wanted to look. They wanted a number and a square root multiplied by something. Just to point out, this was multiplied by something. There was a 1 here. This could have been the right answer. It wasn't. Anyway, that's the answer. That's the last part of question 4. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.